Now that we have these parametric equations for an ellipse, we should be able to take a graphical image and determine the specific equations for that image. Let's look at an example. Here we have an ellipse. What we need for our equation are the values for h, k, a, and b, where h and k are the center, and a and b are the x and y radius. So first let's determine the center. Here's my center. The coordinates for that point are -3, 2. To determine the x radii, I'm simply going to count tick marks. 1, 2, 3, 4, 5 units away from the center. So my x radius is 5. Similarly, my y radius is 2. Now I simply need to incorporate this information into my parametric equation. So x is going to be -3 plus 5 cosine t, the x coordinate for the center and the x radius. Y then should be, I'll pause to let you write it down, 2 plus 2 sine t. And if we check our answer, we see that we have obtained our equation for an ellipse. Well, now we know how to graph an ellipse or come up with the parametric equation for an ellipse. But how can we be sure that what we're drawing is a true ellipse? Well, we're going to use a process called eliminating the parameter. And what that means is transforming a parametric equation to a single Cartesian equation with only x and y. There are various methods to do this. This one that we're going to take will involve some Pythagorean identities. We'll start with the equation x equals 5 cosine t and y equals 7 sine t, which should generate an ellipse with an x radius of 5 and a y radius of 7 centered at the origin. The first thing I'm going to do is divide each of these equations by the coefficient on the trig function. So x over 5 is now equal to cosine t, and y over 7 is equal to sine t. The next step is going to allow me to implement a trigonometric identity. I'm going to square both equations. And by square, I mean square both sides of the equal sign. So x over 5 will become x squared over 5 squared. And that's going to be equal to cosine squared t. And y over 7 becomes y squared over 7 squared, being equal to sine squared t. Now I'm going to combine these two pieces of information by adding them together. So I'm going to add the left sides of the equation, and I'm going to add the right sides of the equation. So I come up with an equation that says x squared over 5 squared plus y squared over 7 squared is equal to cosine squared t plus sine squared t. And hopefully that's ringing all sorts of bells in your memory. Cosine squared plus sine squared is equal to, yes, 1. So now I have the relationship x squared over 5 squared plus y squared over 7 squared is equal to 1. You'll notice I have a single equation in terms of x and y. There's no t value to be found. And we see that our general form of the conic equation for an ellipse matches the equation we derived, where the general form is x minus h squared over a squared plus y minus k squared over b squared equals 1. Now let's just review our questions to make sure we've answered them all. First of all, what is a parametric function? Well, it's a set of equations that are linked by a common variable to describe independent behavior. That common variable is called the parameter. And we've seen that we can generate ellipses by combining trigonometric functions and parametric functions. If we're going to generate these images, we will generally use a full revolution's worth of information. So 0 to 360 degrees or 0 to 2 pi. We can determine our parametric equations by using the general form of the ellipse function. And we can restrict our ellipse image by restricting the t values in our window or by using Boolean variables. Finally, we can justify the image or link it to what we already know in function world by eliminating the parameter and coming up with a Cartesian equation that generates the same image. To eliminate the parameter, we can use trigonometric identities to combine our x and y information. A scary Halloween tale. A man is walking home alone late one foggy night when behind him he hears bump, bump, bump. Walking faster, he looks back, and through the fog he makes out the image of an upright casket banging its way down the middle of the street toward him. Bump, bump, bump. Terrified, the man begins to run towards his home, the casket bouncing quickly behind him. Faster, faster. Bump, bump. He runs up to his door, fumbles with his keys, opens the door, rushes in, slams and locks the door behind him. However, the casket crashes through his door, with the lid of the casket clapping. Clappity-bump, clappity-bump, clappity-bump. On his heels, the terrified man runs. Rushing upstairs to the bathroom, the man locks himself in. His heart is pounding. His head is reeling. His breath is coming in sobbing gasps. With a loud crash, the casket breaks down the door, bumping and clapping towards him. The man screams and reaches for something, anything, but all he can find is a bottle of cough syrup. Desperate, he throws the cough syrup at the casket and, hopefully you're ready for this, the coffin stops.